This is an equation that you're asked to solve for x, and once again it's a rational equation, which means we need to pay attention to the denominators. We can't come up with a solution that would make the denominator equal to 0. So for example, I'll set x plus 2 not equal to 0 because we don't want that denominator to be 0, and the number we want to avoid when solving for x here is x equals negative 2. If I come up with an answer of x equals negative 2, that last fraction here is going to be 1 divided by 0, and you can't divide by 0. Do the same thing with this middle fraction here. Take x minus 2, solve for x, and the number that x can't be is also the number 2. We'll see that if you set x squared minus 4 not equal to 0 and then solve for x, you come up with the same situation. When you take the square root to both sides, x can't be either plus or minus 2 for that first fraction. So as long as you stay away from the numbers negative 2 and positive 2, you're okay for your solutions. The next thing we want to do is factor that first denominator, and that'll factor into x plus 2, x minus 2. And the second fraction denominator is already factored, and so is the third fraction. Now, the reason we want to do this is ultimately we want to clear fractions. Again, this isn't a situation where I can cross multiply because I have two fractions on one side of the equation and only one on the other. Cross multiplication works best and only if you have one fraction on one side and one fraction on the other. Your least common denominator, I take a look at the denominators and see what factors do I have. Well, in the last fraction I have x plus 2. In the middle fraction I have the factor x minus 2. And in the first fraction I have the factors x plus 2 and x minus 2, but I already have those accounted for in my least common denominator. What I'm going to do next is multiply each fraction by the LCD. And in doing this, I'm going to cancel out those denominators so that I no longer have to worry about fractions. So in the last fraction, the x plus 2's go. The middle one, the x minus 2's cancel. And in the first fraction, both the x plus 2 and the x minus 2 cancel, leaving me with only an x in the numerator plus 2 times x plus 2 equals 1 times x minus 2. Go ahead and distribute to get rid of the parentheses now. And once you get rid of those fractions, the problem becomes relatively easy to solve. You just need to collect your x's on one side and your constants on the other. So I'm going to subtract 1x and collect my x's on the left. Anything that doesn't have an x in it is ultimately going to go to the right side of the equation. So I'm going to subtract 4. So I'm going to get 2x equals negative 6, or x equals negative 3. As long as I didn't come up with the answers negative 2 or 2, I'm reasonably sure that that answer is going to work. But if I wanted to, I could plug the negative 3 back into the original function and check to make sure that the equation is true.